Hello, my dear students. We have already discussed basics of kinematics of rigid body and some problems on it. Now we will again discuss about one problem of kinematics of rigid body on sliding of bar. So on the screen, you will able to see this diagram. So the problem which we have to solve is given as here. A bar of AB of length 1 meter has its ends A and B constrained to move horizontal and vertically as shown in figure. Means this bar is constrained to move in this vertical B and in this horizontal position A. The end A moves with constant velocity of 5 meter per second horizontally. Find A, the angular velocity of the bar AB, the velocity of the bar B, and C, the velocity of the midpoint C of the bar at the instant when this axis of the bar makes an angle 30° with the horizontal. So it is sliding, but it is making an angle of 30°. So we have to calculate the instantaneous center of this bar at this instant only when theta is equal to 30°. Okay, so let us begin with the problem. To solve the problem here, first of all, as we are seeing, the velocity VA is horizontal, so we will draw a perpendicular on the tail of the velocity VA and produce two in upward direction. Similarly, at the tail of the VB at point B, at the end point of this bar, so we will again draw a perpendicular and we will extend it till the two perpendiculars intersect each other. So that intersecting point is considered as I, and by this point we join the another point C, which is at the midpoint of the bar. So as we have to also calculate the velocity VC of this C point as well. So IB and IA are now the instantaneous center. So it means to calculate the velocity of VA and VB, then we must know about the values of IB and values of IB and IA, and also IC. So how to calculate the value of IB and IA? So here, as you are seeing, IA is equal to BO. IA right hand side, BO at left hand side, because it is a complete rectangle. So opposite sides are equal. So that is why IA is equal to BO, and it is equal to L sine theta. Theta is here 30°. So 1 into sine 30°. L, the value of L is given, that is equal to L is equal to 1 meter. So here we calculate the value IA is equal to 0.5. Similarly, IB or AO. So AO is equal to L cos 30°. So IB is equal to 0.866 meter per second. Now with the values of IA and omega, we will find and the VA that is already given to us, we will find the value of omega. Omega means angular velocity of the bar. So that is 10 radian per second. By using the expression omega is equal to VA upon IA. Then VB is equal to omega IB. So as we got to know about the omega, that is equal to 10 radian per second. So we put the value of omega here, then we calculated the value of VB. Similarly, in triangle IAC, here, in triangle IAC, angle A is equal to 60°, and this is, here you can see the IA is equal to, that is given to us, and IC value is equal to 0.5 meter. How? As AC is 0.5, it is the middle point. This value IA we have already calculated. Then IC is the third side of an equilateral triangle. So because the angle is in between these sides is equal to 60 degree, so it is a equilateral triangle, and when it is equilateral triangle, all sides should be equal. So IC is equal to IA is equal to 0.5 meter. Now triangle ICA is therefore equilateral, so we get the value of IC is equal to IA is equal to 0.5 meter. Now VC is equal to omega IC. VC, what is VC? VC is this velocity at point C. So velocity at point C is VC, and we got the value of IC. So we can calculate this VC value. So VC is equal to 5 meter per second. So in this way, we able to calculate the velocities of different points with the help of IC, with the help of instantaneous centers, and in which the objects are describing the general plane motion. Thank you.